Hey everyone, it's Bradley Bush again with another algebra video for you. Today we're talking about long division of polynomials. Our to-do list, we have first, what is long division? It's probably good to know, right? And then we'll give you a worked example. And I'll put timestamps in the video description, so if you want to skip ahead, you can. All right, the question of the century, maybe. What is long division of polynomials? Well, it's a method that lets you divide a polynomial by another polynomial of equal or lower degree. And the degree, in case you forgot what degree was, because it's not like you just remember these things, right? The degree of a polynomial is equal to the highest exponent, as long as the polynomial just has one variable, like an x. So you look for the highest power, and that's the degree. So if the highest exponent you see is 5, then it's a 5th degree polynomial. All right, here's your example. Divide 6x to the 4th plus 5x third plus 3x minus 5 by 3x squared minus 2x. So we need to first put things into the right form. So we'll take the 3x squared minus 2x and we'll plop it out front. And then we'll take the 6x to the 4th plus 5x cubed plus 3x minus 5 and we'll put it down underneath. We also need to put placeholders if we don't have them, meaning we should have descending order of exponents. So we should have 4, we start at whatever the largest is. So 4 is the biggest exponent, and then we should have 3, and then, whoops, we don't have, notice we don't have a 2. We don't have something squared. So we put a placeholder in. I just put 0 times x squared. And then we have the x to the 1 column, and then we have the constant column. So we have all of them. We have our placeholder. I like to have column lines. Those are these things. You don't necessarily need those. I just do that because it reminds me that I need to keep different columns separate. Because when you're adding and subtracting polynomials, you can only add and subtract like terms. So we can only add or subtract and something with an x to the 4th with something else with x to the 4th. So the column lines help me keep my items, my like items, separate. All right, let's do this. So the first idea that we have, or the first thing we must do, is we need to make 3x squared become 6x to the 4th. And if we look at the numbers, 3 has got to become 6, so we need to multiply it by 2. And then the x squared has to become x to the 4th, so we multiply it by x squared. Oh, look at that. Right away, we have something. We have 2x squared. It's got to go in the squared columns. Good thing we had a placeholder, right? So we put the 2x squared in the x squared column, and now we multiply that 2x squared by everything out front. So 2x squared times 3x squared gives us 6x squared to the 4th. 2x squared times negative 2x gives us 4x cubed. Now we change the signs and add. When I change the sign, I circle it. Because if I don't remember if I've actually done it. Changing the sign and adding is the same thing as subtracting. I just say change the sign and add because it helps me remember to change both of the signs. So when we add these, what do we get? The first one is 0, which is exactly what we wanted to write. And the next one gives us 9x cubed. Then we can bring down our next one, which is the 0x squared. And we have finished one iteration of this. Now we do it again. So now what we want is we want 3x squared to become 9x cubed. So the numbers, to get 3 into a 9, we need to multiply it by 3. And to get x squared to be x cubed, we've got to multiply it by an x. So we then, you put 3 x plus 3x in the x column. Put a plus there. And then we multiply that 3x by everything out in front. So 3x times 3x squared gives us 9x cubed. 3x times negative 2x gives us negative 6x squared. Now we will change the signs and add. So negative, that becomes a positive. So this is 0 here. Here we get a 6x squared. We can bring down our next term. And what do we have? This is a plus, by the way. Now what do we have? When can we stop? Do you know when you can stop? This is just an iterative process, right? We just keep repeating the same process until when? Well, if you notice something interesting, check this out. The highest exponent was a 4 to begin with. Then we went to a 3, and now look, we've got a 2 right here. So in each iteration, we drop an exponent. We can stop when the highest exponent down here in our work area is 1 less than the highest exponent here, which is 2. So currently they're both 2. We have a 2 here out front, and we've got a 2 here. So one more iteration, and our work area will be down to the exponent down there will be 1, and we'll be good to go. We'll be good to stop. So we're going to do this one more time. So what we need to do is this 3x squared needs to become a 6x squared. So all we need to do is multiply the 3x squared by 2. Let's do that. So we put a 2 up there in the constant column. 2 times everything out front gives us 2 times 3x squared gives us 6x squared. 2 times negative 2x gives us negative 4x. Now we can change the signs and add. So we get 0 and we get 7x. We need to bring down our next one. And can we stop? Actually, we can stop, right? Because the highest exponent down here is a 1 in our work area, and up top it's a 2, so it's 1 less. So we're good to go. We're done. So we can write out our answer. And our answer is right down here. I just circled it in yellow. So our division problem, the 6x to the 4th plus 5x cubed plus 3x minus 5, all divided by 3x squared minus 2x, that's a mouthful, is 2x squared plus 3x plus 2. And then we have a remainder. The remainder came from whatever was left over divided by whatever was out in front. And we just put it up top with the rest of our answer. So there you go. There's your long division of polynomials. A little bit tedious, but not too bad. Hope this was helpful. If it was, like the video, subscribe to the channel, and thanks for watching.